Solve the following logarithmic equation. Log base 2 of the product x minus 4 times x minus 2 is equal to 3. Whenever we have a logarithmic statement that has a variable in the argument of the logarithm or in the base of the logarithm, we're probably better off changing that logarithm into exponential form to see if we can solve it in that form. So we already have a log of one base of a single value equal to a constant. So that's great. That's a perfect, simple logarithmic form. To change that into exponential form, what we have to do is we take the base of the logarithm and we make that the base of our exponential equation. Now, the result of a logarithm, so this number on the other side of the equals, the result of a logarithm is an exponent. So that becomes the exponent in our exponential equation. And then this is equal to the argument, which is this product of two linear binomial terms. Now, we haven't solved the problem yet, but we do have a better understanding as to how to go about solving the problem at this point. So what we're going to need to do is simplify everything. So 2 to the third power is 8. And then if I multiply these binomial terms out, I need to FOIL. So x times x is, of course, x squared. And then I would have minus 2x and minus 4x. And negative 4 times negative 2 is positive 8. And if I subtract 8 from both sides, and the reason I would do that is because I've got this square term here, and anytime you're solving a quadratic, you need to get everything to one side of the equation and have it set equal to 0. So 8 and negative 8 cancel each other out to do that, to give me 0. And that leaves me with x squared minus 6x because these also cancel. Now to solve this, I need to factor this quadratic. And this is a pretty simple factorization. There's just a greatest common factor of x, which leaves me x minus 6. And if I take these two factors and set them equal to 0, I get x equals 0 and x minus 6 equals 0. So that x equals 0 is one potential solution and x equals 6 is another potential solution. Now, the reason I'm calling these potential solutions is because we can't be using any values that lead to a negative argument on a logarithm. So what we would need to do is just test and see. So if I take x equals 0 and plug it into the argument of the logarithm, that would be 0 minus 4 times 0 minus 2. So negative 4 times negative 2 is positive 8. It doesn't matter that it's 8, it's just that it's positive, that's fine. So that is a solution, that checks out. And then we can also test with 6. So 6 minus 4 times 6 minus 2, that would be the same as 2 times 4, which is also positive 8. But it's positive, and that's really the only thing that matters. So both of these are valid solutions to the original equation.